So today we'll be talking about material properties. This is a picture of an atom. You have the electrons, you have the neutrons, protons grouped together in the center called the nucleus. So, atoms are made up of three types of particles: protons, neutrons, and electrons. Protons and neutrons are grouped together in the center, forming the nucleus. More than 99.94% of an atom's mass is the nucleus. Protons and neutrons are heavier than electrons. Electrons have no mass at all. Protons have a positive electric charge, neutrons have no electric charge, and electrons have a negative electric charge. Atoms have a neutral charge because of this. The electrons move around the nucleus. There's actually nothing in between the nucleus and the electrons. The total number of protons will be the same as the total number of electrons in most of the element electrons are arranged in shells. A shell must be filled before starting the next shell. Hydrogen is the only element that has no neutrons. This is SPDF. You can use it to place the electrons in the correct shell. So this is how we place the electrons in the correct shell. It's an atom of calcium. Now we have valence electron. A valence electron is an outer shell electron that is associated with an atom and that can participate in the formation of a chemical bond if the outer shell is not closed. Covalent bond. A covalent bond, also called a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bond. Nucleon. A nucleon is a proton or a neutron, each thing present in a nucleus. Stable. Most atoms are stable. Their protons, neutrons, and electrons balance. Bearing outside forces, a stable atom will stay the same indefinitely. Radioactive. Some atoms have too many neutrons in the nucleus, which makes them unstable. They are radioactive, giving off particles until they are stable. Isotopes. Atoms of the same element can have different number of neutrons but the same number of protons. Having excess neutrons may make isotopes radioactive. Their atomic numbers are the same but mass number differs. These are the examples of an oxygen isotope. So as you can see, the oxygen isotopes atomic number is the same. Basically, the number of neutrons and electrons in the atom are the same, and but the neutrons are different. Only the protons and the electrons are the same. Isobars. Atoms are different elements with the same atomic mass. They have different atomic number but same atomic mass. So basically, in this, they have the same atomic mass, but different atomic number, which means different elements. So you can see over here the atomic mass of sulfur, potassium, calcium, chlorine, argon are all 40. Antimatter. Antimatter is the opposite of normal matter. More specifically, the subatomic particles of antimatter have properties opposite those of normal matter. The electrical charge of those particles is reversed. Antimatter was created along with matter after the Big Bang, but antimatter is there in today's universe, and scientists have not yet discovered why. Matter and antimatter. The periodic table. The mass of the atoms in the elements increases as you go from left to right and downwards the periodic table. Each element has its own atomic number. This tells how many protons it contains. The atomic number increases by 1 with every element. Each element has its own atomic mass. This tells how many protons and neutrons it has in total. This is the periodic table. The atomic mass and the atomic mass. You have the atomic number and this is a magnesium element, metal. And you have the atomic number on the top and the atomic mass down. Periodic table groups. A group is a column of elements in the periodic table. There are 18 numbers of groups. The elements in a group have similar physical or chemical characteristics of the outermost electron shells of their atom because most chemical properties are dominated by the orbital location of the outermost electron. Periodic table of the elements. It says group 1, group 2, group 3, and these are the periods. Here also another picture of periodic table. Ions. Atoms with extra or missing electrons are called ions. Electrons will be less or more compared to protons. They have a positive or negative electric charge and are responsive for many chemical reactions. A cation is a positively charged ion with fewer electrons than protons. They are smaller than the original atom. An anion is a negatively charged ion with more electrons than protons. They are bigger than the original atom. Cation and anions attract each other due to its opposite electric charges and form ionic compounds. Ions consisting of only a single atom are termed atomic or monatomic ions. Two or more atoms form molecular ions or polymertic ions. Octet rule. Atoms need 8 electrons in their valence shell to be full, so they react to form cations or anions. Halogens always form anions. Alkali metals and alkaline earth metals always form cations. Most other metals form cations, whilst most other nonmetals typically form anions. This is a cation, this is an anion. Ionic bond is basically the sharing of electrons. Ionization energy. Ionization energy is the minimum amount of energy required to remove the most loosely bound electron, the valence electron of an isolated neutral gaseous atom or molecule. They increase as you go up and right the periodic table. Because the further away the electron is, the easier it is to remove them. Ionization increase up and right the periodic table. Electron affinity. Electron affinity is the amount of energy absorbed when an electron is added to a neutral isolated gaseous atom to form an anion. The electron affinity increases as you go up and right the periodic table. Electronegativity is a concept that describes the tendency of an atom to attract a shared pair of electrons toward itself. An atom's electronegativity is affected by both its atomic number and distance at which its valence electron resides from the charged nucleus. The electropositivity. The opposite of electronegativity is electropositivity, a measure of an element's ability to donate electrons. Atomic radius. The atomic radius of an element is a measure of the size of its atoms, the distance from the center of the nucleus to the boundary of the surrounding electronic shells. The atomic radius increases as you go down the periodic table. The atomic size gradually decreases from left to right across a period of elements. This means that the nucleus attracts the electrons more strongly, pulling the atom's shell closer to the nucleus. A valence electron the valence electrons are held closer towards the nucleus of the atom. As a result, the atomic radius decreases. Atomic radius increases down and left the periodic table. Main group elements. The main group of elements include the elements in group 1, group 2 and from group 13 to group 18. The main group elements are the most abundant elements in the universe. Periodic trends. Periodic trends are specific patterns in the properties of chemical elements that are revealed in the periodic table of elements. Major periodic trends include electronegativity, ionization energy, electron affinity, atomic radii, ionic radius, metallic character, boiling points, melting points, and chemical reactivity. Group 1 elements. The group 1 elements are also called as alkali metals. All alkali metals have one electron extra in their outermost shell. Their atoms increase as you go down the group. The melting points and boiling points decrease as you go down the group. They are all shiny, soft, highly reactive metals at room temperature. They lose their valence electron to form cation with a charge of +1. They react with the oxygen present in the air, so they are kept in oil. They react with water more vigorously as you go down the group. The most reactive element in the first group is cesium. The most abundant metal is sodium, followed by potassium and lithium. Francium is the most rarest of them all. They are found naturally in salts and never as the free element. The group 1. Group 2 elements. The group 2 elements are also known as alkaline earth metals. They contain soft silver metals. They have 2 electrons in their valence shell, which enables them to form cations readily with the charge +2. Their reaction with water increases as you go down the group. Beryllium is the only element that does not react with water. Group 13 element. Group 13 element is also known as the boron group or icosagens. They all have 3 electrons in the valence shell. Boron is a metalloid while all others are metals. It is also the lightest of them all. The boron group reacts with water more vigorously as you go down the group. They react to form cations via ionic bonds with charge of plus 3. Group 14 elements. Group 14 are also known as carbon group or crystal bonds, except for germanium and the artificially produced flerovium. All of these elements are familiar in daily life either as a pure element or in the form of compounds. All the carbon group atoms having 4 valence electrons form covalent bonds with non-metal atoms. Carbon and silicon cannot lose or gain electrons to form free ions, whereas germanium, tin, and lead do form metallic ions but only with 2 positive charges. Even lead, the most metallic of the carbon group atoms, cannot actually lose all 4 of its valence electrons because as each one is removed, the remainder are held more strongly by the increased positive charge. 14th group. Group 15 elements. The group 15 elements are also called as pinictagons or pentals. They are also called the nitrogen family. They consist of atoms having 5 electrons in the valence shell. Two of the electrons are in the s subshell with 3 unpaired electrons in the p subshell. As you go down the nitrogen family, ionization energy decreases and electronegativity also decreases. The nitrogen family elements often form covalent compounds, usually with oxidation numbers plus 3. Except for nitrogen, the elements are solid at room temperature. Elements density increases moving down the family. Group 16 elements. The group 16 elements are also known as the oxygen group. The first 4 elements are known as chalcogens. The metallic property increases as you go down the group. Electronegativity, the ionization energy, and electron affinity decrease as you go down the oxygen group. The atomic radius and melting point increases. Boiling point, density, and atomic radius and ionic radius all increases down the group. They all have 6 valence electrons. Most of them forms anions via ionic bond. Sorry. 17. The group 17 elements are also known as halogens. They are all nonmetals. Their melting points, boiling points, and atomic radius increases as you go down the group. Ionization energy, electronegativity, electron affinity, the reactivity decreases as you move down the fluorine family. They all have 7 valence electrons. They always react to form anions with charge -1. Group 18 elements. The group 18 elements are also known as noble gases or inert gases. They are colorless, odorless, tasteless, non-flammable gases. They have 8 electrons in their valence shell except for helium. It has 2 valence electrons. Noble gases' outer shell are full. They are extremely stable, tending not to form chemical bonds and having a small tendency to gain or lose electrons. Their atomic radii, atomic mass, boiling point, melting point, and solubility increases as you go down the group. The ionization decreases as you go down the group. They also have the largest ionization energy. The increase in density down the group is correlated with the increase of atomic mass. PT. Thank you. Please subscribe.